So in this video we are looking at how you calculate the diversity of improved meadows and unimproved meadows and how you compare them. And that's alpha diversity then that we're comparing between these two systems. And as well as thinking about the diversity, another really important way in which we need to be able to evaluate the differences between two systems is in terms of their species composition. So what are the species that are actually there and how do they differ? And why might that be ecologically important? So you're going to have data from 4 meadows. 2 of them are improved and 2 of them are unimproved. And we're going to use that data analysis to enable you to answer 3 questions that are associated with this video. And the index we're going to use is the Shannon Diversity Index, sometimes called the Shannon-Weiner Diversity Index. So the questions are going to be the same as are already on your word sheet and that are on your test, word for word. And so what I strongly recommend that you do is that you do the work, you go through, do the calculations, make sure that you've answered all those questions to your satisfaction, that you're happy with the answer that you're going to give. And then once you've got all of your questions ready for this section, then you just go straight into the test and then you just copy down your answers. So the actual doing the quiz bit should be a really fast job for you. It's just a copy and paste of the answers you've already got. So we're comparing data from the Shalford Bridge area, so from the lovely unimproved hay meadows that are there, and also from the traditional silage, the very modern silage fields that are also there. And we should probably say that aerial view there is not actually from Shalford Bridge. It's a much broader set of silage fields just outside Purbeck, actually. That's quite a lot of the British countryside looks like that. Shalford Bridge, luckily, does not look like that yet. It's a much more little matrix of tiny littler fields. So these 4 meadows then, you've got the data in the Excel sheet, and we're going to have a little look at those right now. I'd like you to explore those data, not just to use them to calculate diversity, but to have a look to see what species they are found in each of those meadows, how they're different, and which of them might be more ecologically interesting and useful than others. You can Google some species names. It's a great idea it's a great way of getting some basic information very quickly. And if you ever want to know more, you can go and have a look at their distributions and what other records there are of them within the National Biodiversity Network Gateway. And if you've not had a look at that already, then I really would recommend it. It's not just plants in there, it's all of the UK's biodiversity, all of the distribution maps are there. It's a wonderful resource. So do go and have a look. I've given you the link there. But in terms of the data first, we just have a quick look at that first, and then I'll come back to the business of Forbes or not. So these are the data, and you've got them on your on Brightspace already for you. So hopefully that will be nice and easy for you to find. They are, what you can see are there are 10 quadrats from each of 4 different meadows. There you go. Those are the 4 meadows, 2 improved, and back here 2 unimproved. And what you've got here is the percentage cover of each of these species in each of those 10 quadrats. There's a few more species down here. And I've given you the Latin name, which is always the best one to use because it's the most consistent. Also the English names, because you may be familiar with some of them already. And then also what I've done, I've indicated here on the right hand side, whether they are what's called a forb or a graminoid. And the reason that I've picked that distinction out in particular is because there's some quite strong ecological differences in general between forbs and graminoids. So let me show you. So these are forbs. Forbs are what we often think of as flowers. They are the bright, showy things that tend to have evolved to attract pollinators as dispersal, so insect pollinators to disperse their pollen, and so consequently they provide pollen and nectar as rewards, and they are they're showy flowers to attract these pollinators. They're not all wind pollen. They're not all animal pollinated. So for example, this one down here, sheep sorrel, is wind pollinated, but the vast majority are animal pollinated. So therefore they produce a resource for animals, and also they are often less heavily protected by silicaceous strengthening tissues in their leaves in the way that grasses and sedges and so on are, and so they are a better food resource for a wider range of species. So having a lot of forbs in your meadow means that chances are that you're going to have a high diversity of animal species, particularly invertebrates, using those meadows too. And by comparison, the graminoids are the grasses, but also the sedges and the rushes of this world. And they are entirely, I think, wind pollinated. Therefore, they provide far less resource for invertebrates because they've got no nectar. The pollen they've got loads of, but it's difficult for insects to carry because it's usually smooth surfaced so that it can be dispersed very easily by wind currents. And their tissues for invertebrates tend to be quite heavily protected by silicaceous additions and strengthening tissue. They are actually extremely well evolved to be grazed on by mammals, and in fact the grasses in particular co-evolved with the large mammals because they can grow from their bases again. So they're always going to be an important component of any grassland. It is the graminoids, but the thing that gives a grassland diversity and diversity that's important for animals are the forbs in particular. So then, the Shannon Diversity Index. It's important to note that it's got two elements in it. Species richness, which is often what people think of when they're thinking of diversity. They're just thinking about how many species there are in a system. And something that's actually ecologically very important, which is the equitability or evenness. So the relative abundance of that species richness. It's all very well having 10 species, but if you've only got one of them in any abundance and everything else is just very, very rare, then that's less valuable ecologically than if you have 10 species, all of which are sort of moderately abundant. And you can calculate it for whole sites, which is what people tend to do, or you can actually calculate it for individual quadrats if you ever wanted to. And there's lots of other indices. One that I will point out to you because it's regularly used as well is called the Simpson Index. Sometimes people use it to calculate diversity too. I think that there's a variation of opinion. I personally prefer the Shannon Diversity Index because it allows you to look at the species richness and equitability separately. Simpson's Index, however, is really useful if you're trying to compare dominance, so because it focuses on that. So you can take your pick, but if you are going to pick this Shannon Index, this is its formula. And I know it looks daunting, but it's actually quite straightforward, really. So I'll talk you through it. So H is the symbol for the Shannon Index, and this is its formula. And actually, all its formula means is this symbol is the sum. So it's the sum of two things multiplied together. One of those things is PI, and PI is the proportion of each species in that site. So imagine you've got your 10 quadrats, you work out what the total proportion of one of the species are, let's say red clover, and then so it'd be the average proportion across your 10 quadrats, and then you work out the total average abundance of species, and then you divide your red clover abundance by your total abundance of species, and that gives the proportional abundance of red clover. And so that's PI. And then you simply multiply that by the natural log of PI. A natural log is just a type of log, and Excel can tell you what your natural log of any number is, as probably can your any old calculator. So you get those two numbers, the proportional abundance and the natural log of the proportional abundance, multiply them together for each species, and then just add them all up. And that gives you a negative number because natural logs produce negative numbers. Then you just multiply it by a negative to get you a positive, and hey presto, that gets you H. And to get the two subcomponents of H, S and J, S is the sum of the number of species, so you just add up all your species that you've got in the system, so that's really, really easy. And J, you've got to calculate H first, and it's just whatever the value of H is divided by the natural log of your species richness. So it is actually nice and straightforward. I'm going to show you in Excel how you do it. I've got a couple of slides here where I've just literally written through those steps for you, so you can read through those if you prefer to understand by reading rather than by listening to somebody. And here you go for S and J. But now what I'm going to do is show you how to do it in Excel. Okay, so you can go to this example file that you've got on Brightspace. Here you go. These are the formulas, so that you got them. And what I've done here is I have downloaded 5 of the quadrats from the set that you've already got, and I've also put in their Latin names and their common names as you've got those. And those 5 quadrats, there they all are. You've then can start to work those to produce an overall diversity index for, imagine if it was just these 5 quadrats from this meadow. So the first thing that you do is you want to calculate for each species the mean. And if you go to Excel, Excel's very handy, because if you use the formula average, and you see if you go into average, that is that range there. So you can get it to calculate that. And then once you've done it for one, you just copy and paste it. Oh, now I've mucked up my Excel thing. There you go. Okay, so I now get to show you how to do it properly since I've mapped it up. Here we go. So you go average, and then you do like that. And then you do like that. Here you go. And then you would, once you've got that, you just copy and you paste it all the way down. Okay, so that gets you your mean. Then you calculate, you add up how many species you've got, and you also do the sum of all this mean, and you work out the total abundance. You can do that by doing this. So equals sum, and then you just do the same thing, going down like that. All the ones that you want, pick them all up, close your bracket. It should have popped it up there. And happily, it's the number that I already got. So that's how you work out sum. And I've left the formula for you there. Okay. And then PI is just a proportion of that in the whole thing. So it's going to be that number divided by that number. And here you can see that I've left for you the formula in Excel of exactly how you do that. So it is this number here divided by that number. I can see as I do that, you see that? It says H divided by, so it gets you that number there divided by that number there. Yep. And if you copy that down, what it will do is we'll automatically change it for these. So with this one here, you see it says H9 divided by that number. And that one here will be H15 divided by that one. So that's nice and straightforward. Then here you just work out the natural log of that number. So it's the natural log of this number here. So it's the natural log of PI. So natural log symbol in Excel is ln, and then you just put PI, and that will just take you down all the way through there. And then once you've got here, all you need to do is to multiply that number by that number. And so in Excel, you just use a little star sign to multiply the two together, and there you go. And so that's it. You've got that one times that one. And now all you need to do to get H is to add up all of those numbers, because that's all of those numbers. And then H here, what you can see I've already done, it's the sum of that lot down there. And that's what you get. Okay, now if I'd have just got, if I'd have just put H in, it would have been that sum, it would have been a negative, but you can see I put a little negative into my formula to multiply it to give you the positive value of h. So there you go, you got h. Now, if you wanted to get j, what you do is j is h divided by the natural log of s, which you can just get Excel to count up for you. It does look a little count. And so it's just going to be the that number divided by the natural log of that number. And so that's what j is. J is always between 0 and 1, and the higher it is towards 1, the better the evenness equitability score is. And so the higher the diversity. So there you go. Hopefully you agree that is nice and simple. And you can do that quite quickly for each of the 4 different fields. So instead of doing it for 5 quadrats, just do it for the 10 quadrats in each of the different fields. But exactly the same principle. And out will pop your H, J and S for each of your 4 fields. And hopefully it should show you some nice differences. Okay. So that hopefully gives you a nice idea of how to calculate the Shannon index. It's probably going to be the most of the actual work that's going to take you to do. So take your time over it and hope it goes well. By the way, just to let you know, if your J comes up above 1, you've gone wrong, right? So have a little go, sort of see how you get on. I would recommend, I'd be very happy for you to compare it with each other, and then that way you can make sure that you're all learning together. There's no problem with any of that whatsoever. So yeah, just see how you get on with it. As I say, it's very straightforward. So it's just a case of just doing it all step by step.